Okay, that's the analysis of the demographic information. Okay. Now let's moving beyond counts. Beyond counts. Okay. When your variable is categorical, you can count number. You can count number. But if you want to do another analysis, you have to switch to different function. We can see here mean, standard deviation, skewness, kurtosis. Okay, what is the standard deviation? Standard deviation. Okay, what is standard deviation? Julie, what is standard deviation? Standard deviation, dispersion. It's a dispersion. What is the standard deviation? Okay. Standard deviation, what does that mean? Between the mean and what? Actual result. Actual result. Okay, let me ask them, the classmate how said. What is the standard deviation? Because we talk about moving beyond counts. Standard deviation is not count. Count is the only number. It's categorical data. But now we talk about continuous data. So we talk about one of the statistics that we can apply is standard deviation. But what is standard deviation? What is it?
Standard deviation in what kind of context?
In that context?
Yeah,
I'm not really sure. Your answer is not clear enough. Standard deviation. Ulrich, how about you? Standard deviation. Usually you learn standard deviation in the I think the first semester of statistics. Yeah, the first semester of statistics. What is standard deviation? Average. Vary from the average or mean value. Yeah, right? Okay, Ulrich. Hello, Ulrich. This is the answer. Do you know the meaning that I write on the whiteboard? Distance between the data point and the mean value. in average. Okay, so we can put in average. So in average, the standard deviation, how far the data point from the mean value. Okay. So we usually need, sometimes we need to report the standard deviation in your study, in your project. So we have to learn it. So let's move to another keyword here called skewness. What is skewness? This is also in the first semester of statistics. Yeah. Skew to right or skew to left, right? Skew to right or to left or normal, right? To left or right or it's a normal. Okay, skewness, right? To right to left is not normal, right? We need a normal distribution. And how about this one, kurtosis? Kurtosis? Have any idea? Mindy? Any idea about kurtosis? First semester of statistics. Really? Or you just forget? No. Okay. Different shape of distribution, something like I've drawn this one. This
kurtosis is like how extreme is it?
yeah, it's a shape one or flat one. Flat one, or it's a normal, right? Normal one, right? So it's a kurtosis. We make sure our data is normally distributed. So I have to check skewness kurtosis. Okay? Okay. So now we will move on to the status analysis, especially for the construct or the concept. So as you can see on the right hand side, we have called mean, right? We have called mean means central tendency. It's central tendency or average score for each continuous variable. And standard deviation is a measure dispersion or how spread out the data point. And skewness and kurtosis measure the shape, you see? Different type of shape, the shape of the distribution to check for normality. Okay, good. Okay, now that's the case we use in marketing research. It's called the 85 degrees Celsius. It's a bakery store. It still exists. You can find it somewhere on the street, right? They sell coffee, they sell cake, bakery, something like that. I would like to study their brand image. Under this brand image, we have three dimensions. We have 3 dimensions. Okay, brand value. Dimension 1, dimension 2, brand characteristics, and dimension 3, corporate association. Okay, and under the dimension, we call them is an indicator, right? Indicators. Okay, it's an indicator. Okay. Now we would like to create a report like this. This report is called a descriptive statistic report. We will focus on the first concept called brand image. And brand image we have 9 indicators. For example, we have BI1-1, BI1-2, all the way to BI3-3. We have different column of variable. We have number of cases. We have mean, value, with standard deviation, skewness, and kurtosis. Okay, let's do it. It's not that difficult. You just select the indicators. Select the indicator from left, move to the right panel here. Of course, we have to select the descriptive statistics and select the variable. Okay, and next move down here. It's called statistics, and we can check mean value, and also check standard deviation. For distribution, we check skewness and kurtosis. And on your right side will be your result. Of course, you can check the result like this. That's the result. Now, I want to show you how to do it. You can follow my demonstration. You can follow my demonstration. So I have to select here. And I would like to create another analysis. For example, I create descriptive statistics. Okay. Okay, that's the first step. Right? Now we want to analyze all indicators for brand image. So you have to make sure you select 9 indicators. On the left-hand side, select 9 indicators and click move to the right. Click here. Okay. Got it. And then I like to switch the column and row. What do I mean by that? Here there is row, right? And here it's called column. So I want to switch the position, the column and row. How to do this? Find the function on the left-hand side corner. You can see transpose descriptive table. You just click next function. So let's click it. You see that? Now I already swatch the position, row to the column or column to the row. So it will be easy for us to interpret. And now take a look at the result. In here, we have missing value, column, valid, mean value, standard deviation, minima and maxima. Okay. Okay. Now we don't need minima and maxima. Okay, so we can select here and scroll down to statistics. Click here. And scroll down, then I don't need minima and maxima, just uncheck minima, uncheck maxima. Okay. Then I like you to check skewness and kurtosis. Okay, these two. Then you can take a look at the result somewhere here. Just like this. We have skewness, we have kurtosis. Right? Usually you can just report the result in your paper. If you want to do that, to do multiplication, something like you can open an Excel file. From your computer, you find Excel file, click Excel file. I want to copy and paste the result to the Excel and then to do the multiplication. And that's the Excel file, right? That's the Excel file. Not this one. This one, okay. Move here. There's some downward arrow. Take a look. How to copy and paste to Excel. Somewhere here. Yes. See that again? Descriptive, statistic. Click. Now you have three options: copy the text, and add note. And I want you to do is to copy. So select the first one called copy, and move to the Excel file here, and right click and paste the result. You see that? And then you can use the Excel file to remove some column you don't need. For example, I don't need the missing value. You can just remove it, delete. Okay. New value. Let me take again. Okay, this one is mean value, right? So you just move this mean value to here. And the next is the standard deviation, right? 1.4, 1.446. Okay, so you can just move to here. Okay. Cancel again. Move. Okay. And remove the arrow turn. Remove the arrow turn. Okay. We just need the skewness value. Move to here. And move this one to here. And delete this one. Select this one. Now we can compare the course material. Let me just copy and paste here. Here. Is it correct? You can just copy to compare the result and to Excel. Alright. Is it the same? Yeah, I guess it's the same. That's the table of the descriptive statistics for the non-indicator. Of course, we have other concepts. For example, we have perceived value. You usually have to report all of it. You have to report brand image, report perceived value, also the loyalty, right? So we need just a practice. But next question is, we already report skewness and kurtosis. Can we say our data is normal distributed based on your result? Can we just describe our data set is normally distributed? Can we just, sometimes we just put the table in our report, but we have to describe the table, right? Say something about the table. So how will you describe your table? For example, for this one. How will you describe your table in your report?
First mention the highs and lowest, and then we will
Of course, you can. We have 4 column, 4 variable. You can one by one describe about the mean value, the range of mean value from the maximum to the minimum, or even describe standard deviation. Okay, and then skewness and kurtosis. But the more important thing is we want to say something about the normality or normal distribution. Based on the kurtosis or skewness, can we say our data is normally distributed or not? Can we say our data is normally distributed or not based on kurtosis and skewness? Can we say that? Is our data normally distributed or no? What's your answer? Or you just don't know, how do you describe it? Even you already have the result. Yes, Oliver say, I think it's normally distributed. May I ask why? Why make you say so?
Because when I look through the series, the difference are not drastic, so it tend to fall on that level.
So your description is in general, right?
Yes.
Not very clear. Okay, let me ask, Felix, how would you describe the normality based on the data in the table? Is normally distributed? Regarding the skewness kurtosis,
It's not normal.
it's not normal. Why? When you say it's normal, you should tell me why. When you say it's not normal, you should tell me why.
Because it's not even frequency.
Okay. Okay. So that's the answer from Seth and Felix. How about to ask Helen? Helen? It's normally distributed or not normally distributed? Why? Suppose that we only have 9 variables, 9 indicators in our research. Nothing else. Do you have answer? Or you just ask ChatGPT? You have a lot of assistant, right? ChatGPT, Google Gemini, and Perplexity, a lot of AI you can ask, right? So think about that. Let me ask Amy. How will you describe the normality based on the skewness and kurtosis? In your research report, you have to describe it, right? You not just put a table and not say anything. You have to say something. Any? Julie? Is it difficult to answer? It's normally okay. It's normally distributed. Could you tell me why? Based on the number, which number make you say it's normally distributed? Oh, I guess we have answer, right? You just check a sweeper for something, so you need the answer. Okay, quite close. Okay. I want to show you the slides. Have the answer. Let's take a look. Yeah, checking for normal distribution. As you can see, we have skewness range from minus 0.6 to minus 0.4 skewness, right? It's a range from max to the minimum. And also have kurtosis. Kurtosis is minus 0.6 to minus 0.1. But whether or not we have normally distributed data, you can see that conclusion, since all skewness kurtosis value fall within the critical minus and plus 2 threshold. So within this range, we can say our data is normally distributed, right? Plus 2 and minus 2, this range. If our value fall within this range, we can say our data is normally distributed. Got it? So we can confirm the data, confirm the normal distribution. So please do remember, you have to say something about your skewness and kurtosis based on this threshold, plus 2 and minus 2. Okay, plus 2 and minus 2. That's the threshold. Okay, that's for the normal distribution check based on skewness and kurtosis. Let's move on to the next. The next question we'd like to discuss. Oliver, do you have any question? You cannot access this the week 5. You can see this week 5. Yeah. Week 5. Now week 6. We didn't finish the week 5 material, so we keep working on that. So the next question: how can I evaluate performance of improvement? Okay, let's replace the roles. I would say let's suggest the boy sitting here is Jason. Okay, suppose it's Jason. And Jason had 2 tests, the midterm test and the final exam. The midterm test score is 71, so that's 71, and the class. Okay, that's 9. Yeah, have to close it. Okay. Jason have the midterm exam score 71. The class is an average. Our class in average is 62, and standard deviation is 3. And the term exam, the final exam, Jason got score 80. Okay, and class average is 70, and standard deviation is 5. So I would like to add, can this just simply say the performance of Jason already improved from 71 to 80? Can we say that? Why? Of course, 80 is greater than 71, of course. But why we cannot say the Jason performance has improved? Oh, that's good. We have to compare, right? You see that? We cannot cannot simply compare 71 to 80 because the difficulty of mean and spread. Because the mean value is different. The midterm is 62, but the final exam is 70. This mean value is different. Also, standard deviation is different. In the midterm is 3. The term of final exam is 5. So we cannot compare these two numbers together. Okay, so if we really want to compare the performance between midterm and the final for Jackson, what can we do? Whole sample, yes, already showed you there, the whole sample, right? The class, two time, the midterm, the whole class, whole sample, and the term, the final, the whole sample, already show the average mean value and standard deviation. But how can we compare whether or not Jackson performance has improved? How can we compare? Based on your knowledge, based on your past experience, how can we compare? It's not a mathematical issue. In math, it's quite obvious. 80, right? 80 is greater than 71. It's math, but it's statistics. Statistics is different from math, a little bit different. Okay? Can you see this different distribution? 2 times. On the left, it's midterm, and the right is term. It's final. How can we compare the difference? We have the answer right here, right? Because the difficulty of mean changed. The mean score changed. 71 changed, not 71. We have the mean 62 and the 70. For the whole class, it's changed. So we cannot compare directly. So, what can we do? What can we do? For the raw score, 71 to 80, we increase 9, plus 9. But the relative ranking, do you know what is ranking?